Hello everyone, welcome to another video on differential calculus. In this video, I would like to give you a test of evaluation of limits. We will come back to evaluation of limits after we're done with integration and applications of integration. Now in this question today, we have evaluate the limit as x approaches infinity of 5x squared plus sine 7x all over x squared plus 5. Now when you see sine 7x, a trig function, the first approach that should come to your mind is what we call the squeeze theorem or the sandwich theorem. I have written it down so that we actually cut down on time. So we have the sandwich theorem here, which says if f of x is less than or equal to h of x, which is less than or equal to g of x, when x is near a except possibly at a, and the limit as x approaches a of f of x is equal to the limit as x approaches a of g of x is equal to L, then the limit as x approaches a of h of x must also be equal to L. So basically we are saying you have a function here f of x and you have another function g of x. Now these functions are such that g of x is actually greater than or equal to f of x. They are equal at x equals a, as you can see in the diagram. And then there's another function between them, which is called h of x. Now if we know, like I've indicated here graphically, that as you approach a from left or right, as x approaches a from left or right, the limit of f of x is L. The limit of g of x is also L. The sandwich theorem says because this function here is between the two of them, the limit as x approaches a, either from left or right, of this function here, which is in between them, is also equal to L. That's basically what the sandwich theorem is saying. Now let's see how we apply the sandwich theorem in this question here. I'm going to start with the sine 7x because we have some information about that. So let's go to our page number, this is page 3. Let's go to page 3. Our solution then is going to be as follows. We know that sine 7x is less than or equal to 1, but is greater than or equal to minus 1. We know that. And if you look at the numerator here, we must add 5x squared, all right? So we're going to have to add 5x squared on each and every term here. So we're going to say this implies that, watch this, minus 1 plus 5x squared, it must be less than or equal to sine 7x plus 5x squared. It must be less than or equal to 1 plus 5x squared. Now let me rewrite this. Why am I rewriting? So that the central function here in the numerator should be actually exactly how it's written here in the numerator. So I'm going to start with 5x squared. So this implies that 5x squared minus 1 here is less than or equal to 5x squared plus sine 7x is less than or equal to 5x squared plus 1. It doesn't really matter on the right hand side. Now the numerator has been established. We are now looking at the denominator. Now notice something. X approaches infinity, so this one is actually away from 0. But this term here can never be negative because we have x squared, whatever value you have, you square it, plus 5. This is always positive. And so I am allowed to divide throughout by this expression without actually changing the inequality signs. So we can say this implies 5x squared minus 1 all over x squared plus 5. This will be less than or equal to 5x squared plus sine 7x all over x squared plus 5. And this will be less than or equal to 5x squared plus 1 all over x squared plus 5. Now, this is beautiful because we have now established two functions between which this function lies. You can see it here. This function lies between these two functions. So all we have to do now is to take the limit of this as x approaches infinity, take the limit of this as x approaches infinity, check the answer. If the answer is the same, it means the limit of this central part as x approaches infinity by the sandwich theorem must also be equal to the same value. Now, so we're going to say, therefore, what is the limit as x approaches infinity of the lower function first? So that's 5x squared minus 1 all over x squared plus 5. The way we approach this whenever you have x squared is to divide each term by x squared. So This is going to be, watch this, is going to be limit as x approaches infinity of 5x squared all over 5 over x squared. I'm dividing by that term there, plus, it's actually minus in the numerator there. Let me erase this. My hand misbehaved there. We have a minus term there, minus 1. So it's actually supposed to be minus 1 here. Let me remove this. But we are saying minus 1. Term-wise division, remember I've spoken about this in the previous videos, all over x squared. And we're dividing this by x squared all over x squared, and then plus 5 all over x squared. Now, this doesn't change the function. You can actually verify this by using numbers. You'll find that this is actually correct. Now, let's simplify this. So we're going to our next step. This is equal to limit as x approaches infinity of what? Of, notice here, the x squared cancels. So we have 5 minus 1 over x squared. All over, here it's going to be 1 plus 5 over x squared. Now, notice something now. As x approaches infinity, that term there will approach 0 and that term will approach 0. So this is going to be 5 minus 0 all over 1 plus 0, and the answer is just 5. Remember, 5 minus 0 is 5 all over 1 plus 0 is 1. So 5 over 1, the answer is 5. We're done with the lower part. Let us now work out the limit as x approaches infinity of the upper function. Right, let's go to page number 4. On page 4, basically we are now saying the limit as x approaches infinity of what? Of the upper function, this part here, of 5x squared plus 1 all over x squared plus 5. We're going to use the same trick. Term-wise division, we're dividing each and every term. Remember, when there's a plus or minus, you are allowed to do that. So let's carry on. So this is going to be equal to limit as x approaches infinity of what? Of 5x squared all over this x squared here. We're taking the x squared in the denominator. Remember that. All over x squared. And then we have 1 plus 1 all over x squared. We're saying all over down here. X squared divided by x squared plus 5 divided by x squared. And then we simplify this. So this is going to be equal to limit as x approaches infinity of that part there, the x squared will cancel. You have 5 plus 1 all over x squared. And then we are saying divided by, this is going to be 1 plus 5 all over x squared. Again, notice something. This is exactly equal to 5 plus 0 all over 1 plus 0. And the answer is 5. So now you see that the upper function gives us a limit of 5 as x approaches infinity, as you have seen it here. The lower function here also gives us 5 as x approaches infinity, as I've described or explained here. Then we're going to say, therefore, by the sandwich theorem, comma, the limit as x approaches infinity of 5x squared plus sine of 7x all over x squared plus 5, this must be exactly equal to 5. Remember, this function here is what we had in our original question. There it is. The limit as x approaches infinity of 5x squared plus sine 7x all over x squared plus 5. This must also give us 5. Because this function we managed to establish that is between these two, and limit of that and of that as x approaches infinity is giving us the same value. Therefore, the central part must give us also the same value when it comes to the sandwich theorem. Right. Like I said, we'll come back to this and many more techniques of evaluating limits when we are done with integration and applications of integration. All right, so if you're new to this channel, please support us by subscribing and inviting friends to subscribe. Please give us feedback. We appreciate feedback, and I try as much as I can to respond to each and every comment. Yeah, so we'll see you in the next video.